Hi, very good afternoon. So today I'm going to explain Aloha. So to be precisely starting Aloha, what is Aloha? Let's start with multi-access protocols. So Aloha is relevantly in multi-access protocols. First multi-access protocol is classified into three types. One is random access protocol, the other one is controlled access protocol, and the other one is channelization protocols. So first, let's come with random access protocols, that is Aloha, CES, MA, and CD. So we are going to now discuss about Aloha. What is Aloha? Aloha is generally each station can transfer the data anytime, no restrictions for data transformation. I mean, for example, I'll show you the reference. So let's see, let this be the reference. For example, you can now A here, as here, this is A, this is B, and this is C, and this is where A and B is being whereas A and B is getting collision. So this collision can happen, like there will be no data transformation. So for example, I'll take you the reference. There is this data here, data 1, and there is one data here, and one there is data here, and one data is here, and one data is here. So this is a flow of data. Okay, this package is being sent without any collision. But here when you see, there is a collision that has been happening in second package and first package that has been sent, and there is a collision between third packet and fourth packet that has been sent. So this collision that can happen, I mean, without any sort of disturbance, is the collision that can happen, is genuinely called as Aloha. Is that clear? So as per now, that is clear, right? So I'll show you the rough diagram. Station 1, let's say 1.1, this is 1.2, and station 2, 2.1, 3.1, 4.1. The place where the collision is called collision duration. So this can occur in Aloha. So we'll get questions like find collision duration. If the package is going on, every last package is collected, then it is called, we can find collision division. What is collision duration? So what is collision duration, it is called. So generally the collision happens with, even if the collision happens with the last package, it is called as collision duration. This can happen only in Aloha. Collision duration can happen only in Aloha, and this is completely normal. When this collision happened, the package will go on with the flow, and the package will not go back. Okay, is that clear? Fine. Now let's moving on to the next one, that is a question from Aloha. So this is a question from Aloha. I am going to show you the question. So this is the question. The question that is given is, a pure Aloha network has been shared channel of 200 kbps. What is the requirement to make this frame collision free? This solution, I'm going to explain this solution in a very brief way. So first, what is given to us? Let's write what is given to us. For us, L equals to L and BW is given. L and BW is given. L is 200 bytes. If you can see the question, L is 200 byte and BW is 200 kbps. Now this is a formula. Capital T, small t equals to L by W. That is 200 by 200 into 10 to the power of 3. This is a formula. Okay, that will be 1 into 10 to the power of 1 second. Okay, now we found TW. So 100 frames per, and we have given that. So there's a question cut here that shows like 100 frames per second. Okay, so generally 1000 frames per second. So capital T, small t is given by 1 ms. Now while explaining you how to find G, Okay, this is very, very important, so I want your concentration on here. So 1000 frames is equals to 1 second. Okay, so 1000 frames takes 1 second for the refreshment rate. What 1 milliseconds, what is 1 millisecond? Like what 1 millisecond, how many frames, or how many how many frames will be done. So to calculate this, we can do it. 1 second is equals to generally 1000 frames. That is what we have given, right? That is a general formula. Okay, so 1000 milliseconds is 1000 frames. Then 1 millisecond will be how many frames? 1 frame. That is 1000 by 1000. Okay, understood? Is it clear? And this has to be in your mind. And with this process, we are going to find G. So this is how we find G, where 1 millisecond is given as 1 frame. This is 1 frame. Therefore, G equals to 1 millisecond, 1 frame. Now we're going to substitute this in our formula. S equals to G into e power minus 2g. This is a formula to find what is collision free. To find collision free, this is the formula that we use. G into e power minus 2g. So by substituting G, we know 1, and E is 2.718. So we have to be keeping in mind value of E. E is a constant value. We can see in your calculator also if you want. If you want, I'll show you in the calculator. So if you can wait a minute, sorry. So E, if you go up here and have a scientific calculator, value of E would be here. E equals to 2.718. Okay, so E equals to 2.718. This is the value of E. Substituting E, that is we get 1 into e power minus 2g, that is 1 into 2.718 into minus 2. So if we calculate this, we'll get 0.135, and this is the final value. Okay, so clear? Now let's dive into a simple example. For suppose now let's say G is given as 18 seconds. Okay, like what if it is 18 seconds? Okay, so if it is 18 seconds, then I'll tell you what is the calculation. For example, it is given that, let's say, I'll tell you a brief example. Okay, 18 people built one wall in 5 minutes. Okay, then the same way the same wall would be built by 10 people in how many seconds? So this is a 10th class question. I mean, it's a basic small question that we're going to do. I guess we are also aware of this. We must have done this when we are in our basic medium of our class. So we know what will be the question. In the same way, let's say that is given 1 second is, in 1 second, 25,000 frames. Okay, as in given the question, like Aloha network transmission 200 bits, and the frame of one channel is 200 kbps, right? Instead of 200 kbps, it is given that 25,000 frames has been done. So to calculate 25,000 frames, then what we do is 1000 milliseconds is equals to 25,000. Okay, 1 millisecond is 25,000 by 1000. Okay, that is how we do this. Right? In the same way, cancel, we get 25. So 1 millisecond is 25. Okay, So now that is how we do for all if it is given that that is 18 milliseconds. Okay, for example, g is 18 milliseconds, and then we do s equals to g into e power minus 2g, right? So let g be 18 milliseconds, and 18 milliseconds 25 into 18. So what is 25 into 18? This will be our g value. Substituting g into this formula, that becomes the formula, right? G into s equals to g into e power minus 2g. So then g, what is g? G into 25 into 8. 25 into 8 into 2.718 minus 2 into 25 into 8. So if we find this value, we'll get the initial okay. So this is how the question is being asked. Like I'll show you how the question will be asked. See, this is how the question will be asked. Okay, a pure networking transmitting 200 bits frame on a shared channel for 200 kbps. What is the throw output if the system, all systems together, produced? So it is given 1000 frames per second, 500 frames per second, 250 frames per second, and whatever we have given, so it is going to be the same. So per second, it is given per second instead of per second. It is, if it is given 8 seconds, if it is given 18 seconds, you have to just multiply, as I've showed you. You have to just multiply this 25 into g, so you get the initial value. That is how it is done. So if you want the solution, it is given below as well. So let's take again for a brief explanation. I'll explain you how to do it. So for us, it is given 200. I already explained you for 1000 bits. This is how it is done for 1000 bits. Same as for 500 bits. It is now let's take 500. So 500 frames, and 5 for 1 millisecond, that will be 5 seconds. So g will be 5. So if for 500 frames per second, it will be 500 g s equals to g into 2 to the power of, s equals to g into e power of minus 2g. So your s will be 5 into this is for 500 frames, this is for 500 frames, 5 into 2.718, right? Yeah, minus 2 into 5. So if you solve this, you'll get your final answers. So this is how the questions will be asked, and the final question that has been asked is difference between pure and slaughtered Aloha. Okay, so this is how you might get a question for 2 marks, or you might get a big question for big theory question. If our luck is good, you might get a big theory question, and you might get a question like this, what does an explanation. Okay, so difference between pure and sorted Aloha. So now let's I'll first briefly explain you the formulas for pure Aloha. Pure Aloha, to calculate the collision time, we use 2 into t to the power of t small t. So I've showed you how to calculate t equals to t small t. This is how you have to calculate t small t. This is a formula for pure Aloha, and for sorted Aloha, to find it, we just use it t into t. So simple, as simple as it is. And to calculate the data transformation of data package, I mean this all is called, this solution that we did, the formula that we did, it is called transmission of data package. So for that, this formula is 2 into e power minus 2g, and for this it's just g into e to the power of minus g. Okay, for slotted Aloha and for normal Aloha. And maximum efficiency, so what will this efficiency, efficiency of normal Aloha will be 18.4%, and for this it will be 36.8%, and at g equals to 1/2, at g equals to 1. Like if there will be a question asked as like before we saw, and that your maximum efficiency, use maximum efficiency of pure Aloha, then we have to write 1.84%, that is the whole solution, that is half. I mean, for example, if it is 1 by 2, if it is 18 by 2, if it is 18, then we have to do 18 by 2, occurrence of 18 by 2. So I'll tell you a difference between pure and sorted Aloha. So pure Aloha, any session can transmit the data anytime. Okay, there will be no data, as I've told you in the starting itself, there will be no data reoccurrence, and there will be no data collision. So data collision can happen, there will be no boundaries for the data to transfer. But whereas coming to slotted Aloha, any station can transfer the data at the beginning at any time slot. I mean, for pure Aloha, it can transfer data anywhere. I mean, it can start the data in the starting, it can transfer the data from the starting, it can transfer the data from the beginning, starting, ending, in the middle, it can do anywhere, it can transfer the data. But coming to slotted Aloha, it can either send its data in the starting or ending of the state. I mean, if it wants to start a new data, it has to start from beginning or ending. In middle, it can't. So that is the simple difference between sorted and slotted and pure Aloha. So prepare well. I'll be sending you the photos as well. For any explanations and questions, you can totally message me out. Thank you.